Earth is gigantic, but no one really seems to understand just how gigantic it really is. This often leads to all sorts of strange, convoluted ideas about what the Earth looks like and how it works. The diameter of Earth is around 12,742 kilometers, or 7,918 miles, making a circumference of 40,030 kilometers, or 24,874 miles. But there's a big problem. What does this even mean? Who even knows what 40,000 kilometers is? It's a large number. And that's about where it ends. But fortunately, the video does not end here, because the Earth is gigantic more than you can believe. But in order to get a better idea about the scale of the Earth, we're going to need to increase our dimensions. This is any average person standing on the Earth near sea level. Looking across the Earth at eye level, you'll see something like this. From this perspective, it is impossible to get any idea of how big the Earth is, other than just big. But maybe removing some of the visual obstacles will help. That still looks pretty flat. Well, anyway, if we ascend to the tops of the trees, it looks pretty much the same. Even at the very top of the Burj Khalifa, the tallest building in the world, there's not much more to see, with the exception of a few distant mountains. Ascending to the tops of the mountains, there's still no clear reference for the size of the Earth. Even removing the visual obstacles for a clear view of the horizon, the curvature is minimal. I think it's clear at this point that the Earth is rather large. Ascending to the cruising altitude of airliners, the Earth still looks remarkably flat, but this should come as no surprise for the reason that the Earth's design is absolutely gigantic. At 100 kilometers, the border of space, the curvature is now quite visible, but even in space, the Earth appears to extend on for quite some time, likely because it's gigantic. Anyway, if we ascend to over 4 times this altitude, we'll find the International Space Station. At this point, we can clearly see the curvature of the Earth, but even 4 times farther than the edge of space, you can still only see a small section of the Earth. Here's the thing though. We're 4 times farther than the border of space, but if we take a bit more than a step back, we can see that we aren't actually that far above the Earth. It almost looks as if we're only a few dozen kilometers above the Earth, not several hundred. Looking at the cruising altitude of airliners from this perspective, it's easy to see why the Earth was looking so flat when we were at that altitude. Viewing the entire Earth certainly gives a different perspective. Speaking of viewing the entire Earth, this is Mount Everest. Oh, what, you don't see it? Well, it's right here. Not like in the real world, but I mean like, that's where it is here. Or, I mean, it's not like actually, even viewing it in 8K, you can barely see it. And in reality, it'd be even more difficult to see Mount Everest because of all the other mountains surrounding it. And while we're viewing the entire Earth, we might as well try traveling around it. Walking around the Earth would take a full year, obviously ignoring the water and whatever other obstacles you may encounter. Driving around the Earth at standard highway speeds would take around 2 weeks of continuous driving, again, ignoring any obstacles. Flying around the Earth in an airliner would take 2 full days. Even traveling around the Earth at the speed of sound would take 32 hours. But you might actually be traveling faster than this right now. The Earth is so large that despite taking nearly 24 hours to make one full rotation, anyone near the equator will be traveling 1,674 kilometers per hour, or Mach 1.3. Well, except that the Earth is also orbiting the Sun, and the Sun is orbiting the Milky Way, and But at least the air is moving along with you so that you're not being faced with supersonic winds. Oh, and fun fact, because of the Earth's spin and its shape, you actually weigh less at the equator than at the poles. Your mass is still the same, it's just your weight is less. But the change in weight is very negligible, so you'll likely never know. Anyway, Earth has a surface area of 51 billion hectares. This means that if every person on the Earth were spaced out with equal distances from everyone else, each person would have over 6 hectares entirely for themselves. Well, except nearly 71% of Earth is covered with water, but even only counting the surface area of the land, each person would have over 1.8 hectares all to themselves. Well, and probably some animals, trees, rocks, and whatever else. Okay, but let's try scaling everything down a bit. If you were half the height of a grain of sand, the Earth would be about the height of 450 houses, or about the depth of the Grand Canyon, or more than twice the height of the Burj Khalifa. Speaking of the Burj Khalifa, at this scale, the Burj Khalifa would be about the height of a light bulb. Mount Everest would be only a little taller than a trash bin. And despite many people thinking the moon isn't nearly as big as it is, at this scale, the moon would be taller than the Empire State Building. Remember, you are half the height of a grain of sand. Oh, and the sun at this scale would extend 2 times farther than the edge of space.